All right, let's continue on. Let's look at the Java integer data types. We first have the byte. The byte gives us 8 bits. The value is going from minus 128 to positive 127. We have a short, which is 16 bits. We see the range of that. We have an int, probably the most commonly used of the integer data types, the int, which is 32 bits. And then we also have a long, which is 64 bits. And one of the aspects of the Java language is that each one of these, no matter what machine it's running on, that is the value, that is the number of bits. It's guaranteed to always be that, as implemented by the virtual machine. So when we look at the Java byte data type, again, it's 8 bits, going from minus 128 to plus 127. And as with the other primitive data types, it also has a class that goes along with it, so the java.lang.byte. And notice I mentioned a few of the items that go with it. For example, the java.lang.byte.min value. So you don't have to really remember the minimum values, minus 128. It's defined for you as min value. And there's also a byte.max value. Probably the ones you'll use most often is the parse byte. Notice parse byte, you can give it a string and it will parse that string. Let's say you have a string of 100 as a string. Well, it would parse that into a byte having the value 100. Or another example, notice you can do a parse byte where you give the radix. So you can basically say whether the number is base 10, which is the default, or perhaps you want to do a base 16, which is another common one. Hex or base 16 is often used, but you can put any radix there and it will parse it as that. We also have a short. Again, it's 16 bits, and with the short, it also has, besides the primitive called short, spelled in lowercase, there's also the java.lang.short, the class itself, and again, notice it also has a min value and a max value. And once again, the ones you'll use most often, you can parse a short, either parse it as a string or parse it with a string and give it the radix if you want to parse it, say in base 8, or most commonly, the one I've used most often is base 16. Same thing with the integer. As I mentioned, this is probably the one you'll use most often, an int, or the class that goes along with it, the java.lang.integer. Notice that the java.lang.integer has the min value and the max value defined, and like the others, it has a parse integer and also a parse integer with the radix. So both cases you can give it the string and it will convert it into an integer. The last of our integer data types is the long being 64 bits, and it also has a java.lang.long, a class that goes along with it. And we see, like the others, it has a min value, a max value. It has a parse long, so you can give it a string and it'll turn it into a long value. And again, if you want to have the radix. So declaring them, you've probably done this many times. For example, int counter, if you want to declare it, a variable called counter that's of type int, or if you want to declare it and assign it a value, here I have an int number equals 1, 2, 3, 4. The operations we can do on this, we can add and subtract, we can multiply and we can divide. And the other one you use quite often, actually, in coding is this remainder operator, the percent operator. So the percent allows you to divide, but what it returns to you is the remainder. So here's a coding exercise. As always, make sure you enter this and run it. First, notice at lines 6 and 7, show the minimum and maximum value of the byte. And at line later on, basically the code takes each one. So at line number 9, we see we're doing a short. And at line number 11, notice I'm doing the parse of the short. So actually parsing in this case 2. And at line 13 and 14, you see I show the min and the max value. Notice for all of these, you can see the output on the right side of the screen. And although you can see it on the right side of the screen, I definitely encourage you to pause the video as you're watching it, enter this code, and make sure you get the same results I'm getting. At line 16, we see using an integer. I have an integer in a variable called n3, which is event, and set it equal to 3. And we also at line number 18 do a parse int, showing that in action. And at line 20 and 21 show the min and max value of that. And last at line 23 we do a variable n4, which is of type long, setting it to 4. At line 25 we do a parse long to show how we can parse it, and then show its min and max values. Pretty big numbers there for a 64-bit number. Okay, we also have floating point types. So we begin with the float. The float gives us 32 bits, also referred to as single precision. And note that the default, the default for the compiler always uses double precision, that is a double. And so if you specifically want to use a float, you need to put an F there, like I have the 3.14 F. The F would tell the compiler that you want it to be a float as opposed to the default being a double. Speaking of double, that's our other floating point type. This one's 64 bits, and this gives you double precision. And as we stated, this is the default. So typically you'll just use the default of double precision and not worry about it. So here's some examples. The first bullet, we have a variable n1 that's of type float. Notice the second bullet, I wanted 123.4 to be a float, so I had to put the F on the end of it. Otherwise, the compiler would give us an error saying that n2, you've defined, or you're declaring n2 as a float, but you'd be trying to set it to a double. So by putting the F at the end of it, we know that it's of type float. And then the third bullet, we have a D3 for double, and then a D4 where we set the default value, the 123.4, which is interpreted as double precision. The operators for floating point, you can do addition, subtraction, multiplication, and division. So here's an example of doing the floating point. Again, I encourage you to type in this code and run it. The ones that are probably most interesting, notice at line 6, we can do a parse float. So if you need to parse something into a floating point value, notice that you can give it a string and you can indeed parse that. Also, you can see at line 8 and 9, the floats can also show you the min and the max value. So notice we've got the min and the max value from that at line 8 and 9, seeing the output on the right side of the screen. And then at line 12, we do a double, F2 equals 6.28. And here, I want to draw to your attention again, the line 14, we can parse double. And so that way we parse this, taking the string, turning it into a double value. And boy, talk about a huge value. Notice 16 and 17 showing the minimum and maximum value. So very, very tiny and very, very huge values are available from that.